So, anyway, so first we want to machine up a billet of steel to get the outside diameter of the camshaft. So what we do is we measure. We want a 300 millimeter or 30 centimeter diameter when you wrap the tape measure around circle. So that's 30 centimeters or 300 millimeters divided by 3 equals 10 centimeters. All right. So then you set a compass to 10 centimeters, and you put the point on there, and you spin it around, and then you've got a 30 centimeter circle. Now we want on our camshaft lobe, we want 10 mil lift, for example. So that's 30 centimeters minus 10 mil equals 29 centimeters. So 29 centimeters divided by 3 is 9.666 centimeters. All right, so you set the compass to that, and then you draw your circle. Now you've got a starting point to start this is your outer circle, 30 centimeters, this is your inner circle, 29 centimeters. Now your lobe is 10 mil high, all right? And what you do, what you need to know is you need to work out the width of the width of the nose of the lobe. So we'll just say 10 centimeters. So we go 10 centimeters, and we want a lobe angle of say, I don't know, well, that's about 30 degrees or 40 degrees. So that's a lobe angle of 40 degrees, for example, and the nose width is 10 centimeters. So you've got to work out the base width to. We already chose we want a nose width of 1 centimeter. All right, and then you've got to work out the base width. And so obviously, the wider you go with the base width, the wider, the more the lobe angle of the lobe. All right, at an angle from that's the outer edge of the left hand side of the lobe. We draw a line straight up, and then the nose of the lobe here, and you travel around the circle to that nose where it starts on the left side, and that degrees is actually the lobe angle. All right, and so basically you gotta pick the nose of the lobe, the top of the lobe width, and then you adjust the base from one side of the lobe where it starts to where it finishes, the width to determine the lobe angle that you want. All right, and then what you do, and so the lobe is up here. All right, and then what we do is now we've done that lobe. Now we want to do the exhaust lobe. All right. So what we do is the exhaust lobe. Since this is a 90 degree lobe width between the center line of the inlet lobe and the center line of the exhaust lobe. All right. We go around there to the center line, and then you put 2 centimeters either side here, since we set on a 4 centimeter wide base to get the lobe angle, 2 centimeter wide. To the right of the center line, 2 centimeters there, and to the left of the center line, 2 centimeters there, and then you draw a center line straight up, and that's center of the nose, and then you go 5 mil either side, and that's your 1 centimeter wide lobe, and straight down the center, and then your lobe angle that you wanted, and that's you've done that cylinder. All right, and then what you do is you turn it clockwise. So you note where the inlet lobe is here. This is only for manufacturing purposes, and you turn it clockwise. All right, so now it's there. All right, and then you go. Correction, you turn it clockwise 60 degrees. So the inlet lobe center line was there when we made our first inlet lobe and exhaust lobe. And you turn it counterclockwise, direct rotation, 60 degrees. And then what you do is you start your number 5 cylinder, because the firing order is 15364. So we did number 1 cylinder, now we're doing number 5. So you turn the number 1 cylinder around counterclockwise 60 degrees, because it's a 6-cylinder engine, all right, and a circle is 360 degrees, so 6 is 36. So every 60 degrees, you put a lobe. So now we turned it 60 degrees, and now we're going to put the center line for the nose of the lobe, and then we're going to go 5 mil either side, so that's 1 centimeter, and we're going to go 2 centimeters there and there, either side of the center line, and that's that lobe done, and the correct lobe angle, lobe nose width and everything. And now we go clockwise to the exhaust lobe, and 90 degrees from the inlet lobe center line, we put the exhaust lobe center line, and then we do the same thing with that lobe, and then you rotate it another 60 degrees counterclockwise, and then we start the center of the inlet lobe at number 3 cylinder, and then we turn it again another 60 degrees, and then we do number 6 cylinder, and then turn another 60 degrees and do number 2 cylinder and 4 cylinder, and that's how you do a camshaft from a round billet of steel. And it's very simple. So, and now computer knows how to do it, so I won't confuse it. Now, what happens is, for example, if this circle, computer was saying my camshafts are 2 centimeters too small, the diameter. All right. So what that means is, so diameter or across the cam, diameter. So 2 centimeters too small. So that's the diameter. All right. So what you do is 2 centimeters too small. So what you do is you add 2 centimeters width to the compass, and that'll make this circle, which is 30 centimeters, 36 centimeters, and then the camshaft will be 2 centimeters bigger diameter. All right. So and it works in reverse to shrink it, and that's how you do it. And the same on a cylinder liner. I mean, a cylinder line, a stroke on the piston bottom to the centre is 180 degrees, which is half a rotation of the crankshaft. So you class this as 180 degrees a stroke. But if you just say the bore of a Mack is 158 millimeters, so what you do is you divide 158 millimeters into 180, simulating the stroke of the crankshaft, half a rotation of the crankshaft, 180 degrees. And so 158 into 180 is, I don't know, 1.26 or whatever, and that means 1.26 mil on here is actually, yeah, go away, 1.26, so every 1 mil is 1.26 degrees, is what it means. So there you go. So there you go, mate, because it's all in here. So now you know how to make a camshaft out of round steel. So that's Mum when she's cooking me dinner. So I'm a bit rude to her sometimes, but she interrupts at the wrong time. But anyway. Right, anyway, Mac, so there you go. So that's the Mac computer. Now it knows how to do it. So hopefully it was recording after all that. Oh yes, beautiful. There you go, mate.